Hi, everybody, and welcome to the Water Online Show. My name is Angela Godwin. I'll be your host today, coming to you from AWWA's ACE convention here in Denver, Colorado. Joining me today, my guest is Krishna Prashanth. He is with ABB. Krishna, thank you so much for joining me today. I appreciate it.
Thank you very much for having me here.
All
it's
right,
interesting.
Well, we're excited to catch up with you. And one of the things I want to talk to you about first is demand management. All right. So why is this becoming such an essential strategy, especially, when we think about climate change and urban growth?
I mean, it's demand management it used to be an option for water utilities at one point of time. It's no more an option. It's pretty much a necessary strategy in every water utility across the world, whether it's Denver in Colorado or Delhi in India. That is the thing. The reason for that is basically the idea that you can always address the gaps in the availability of water by adding new supply sources like, desalination or dams or dig up more bore wells is proving to be not enough, point number one. Also proving to be way too expensive. So and demand management used to be about, all right, okay, we have some leaks, we have some extra consumption. What we see now is that we are losing 33 trillion gallons of water every year, right? So it's way too much. So the strategies are now more focusing on how to address the demand. And when it comes to demand management strategies, firstly, there is the whole behavioral part of things, consumer behavior, addressing consumer behavior. Then there is policies which are trying to, regulators are trying to address this, and all of them with the backbone of technology. So today you have the technology to be able to very efficiently manage your water networks. And that is why it is becoming economically, from a practicality standpoint, from a sustainability standpoint, it's relevant. And you spoke about climate change, and there are two pressures that people are facing today. One is, I often say this, we say climate change, and really it's a water cycle change. If you really think about it, the real issue we have is that we have all been living in a paradigm where we knew at what place, at what frequency, at what intensity it would rain or it would snow. We seem to be missing that much. There are floods, there are issues. So climate change is an issue to contend with. The other one is rising urban population. So pretty much 70% of the population is likely to get into urban centers. So demand is increasing by the day, and therefore managing that demand is becoming super important.
Wow. Yeah, a lot of very important things converging here at this point, making
absolutely.
Demand management so important. What are some of the most effective strategies you've seen for helping utilities adopt strategies to reduce non-revenue water, for example? Does automation maybe play a role?
Absolutely. First of all, NRW, or non-revenue water, as you put it, is such a huge challenge. I was talking to one of the customers here at water utilities here at the conference, and he said a very interesting way of looking at it. It's like you have a shop and you're running out of stock of whatever, bread or chocolates, because there are shoplifters, right? And instead of addressing the shoplifters with CCTV cameras or whatever, you decide to keep on buying more and more bread.
What a great analogy.
Exactly.
That's amazing.
So the idea of NRW reduction is precisely addressing the shoplifting. And today's world, literally 1 out of every 3 bread loaves, 30% of water is pretty much getting lost. All right. So automation is playing an important role. The first strategy for NRW reduction is often segmenting your water networks to start trying to understand them better. In many parts of the world, they call it district metered areas. Basically, you segment them to try and understand the behavior of the parameters like the flow, the pressure. And then you start using those data to try to address issues. Like, for example, in the night, generally there is no consumption of water. Now, if you actually start measuring your night flow consumption, you start noticing that, okay, there is this consumption that is happening, which is new. It wasn't there like a week ago. It's come up now. And then people start noticing that to try to earmark areas where there could be loss of water, etc. You speak of automation, and automation has come a far way now, you know. it's not just about measurement anymore, because I keep talking about the Aquamaster 4, a technology where you're not only going to be measuring, but you're going to be taking extremely acute decisions because of its low flow capability, and being able to measure pressure with, let's say, a P100 series pressure, and then being able to observe transients. So pressure transients are very unhealthy for water networks. So you start not only noticing the leaks, but also predicting that, look, this network is likely to have a problem. And so that is a fundamental strategy of demand management, NRW reduction, and automation is in use also in other spaces. For example, in industrial output, where water is lost into the discharged, or it needs to be treated, and then you need to reuse or recycle the water. So and then you need to measure a lot of parameters. It used to take like around 5 days to measure something like the biological oxygen demand or the chemical oxygen demand. It used to take 5 days. You take a sample of the water, take it to the lab, let it grow, the cultures to grow. It used to take 5 days, 10 days. Now you have technology and automation available like the UV tech, where you can pretty much do it in 5 seconds. So you pretty much know online right now what everything is happening. And with all this data, you can make much better decisions in controlling the NRW.
Absolutely.
So it's a very exciting time to be in this space.
It really is. I mean, you talk about that 5-day turnaround. You're only getting a snapshot of that water on that particular day when the sample was made. A lot of could have happened in those 5 days,
Absolutely.
right?
Yeah.
So, all right. So let's talk about some real world examples. Do you have any anecdotes that you can share with us about where automation has, really made a measurable difference?
Wow, there's quite a bit of them, and I start with your comment that you made about the snapshot and looking at things in the future. Today's automation with let's say something like the Aquamaster 4 technology, you can not only know what's happening now, but you can go back in time to find out what happened at 3 a.m. in the morning last night. So you may not have measured that point, but you feel that there is an anomaly, and then you can go back in time. So pretty much we call the Aquamaster the time machines of the network. We deployed the Aquamasters in a very large water utility very recently in the Americas, and the city was facing a severe shortage of water. The whole leak reduction, low flow measurement, along with being able to measure huge water flows through from reservoirs and ducts, as much as pipes which were 3 meters high, big diameter pipes. It took close to around 8 months in implementation, and the total water demand of that, with pressure management, of course, water management of that city was brought down to something like 15%, and actually 17%. 15% was the target. We brought down to 17%. Wow. Now that's a big change. I mean, let me tell you an interesting fact. With the very low flow measurement capabilities like we implemented in this particular site, typically most measurements would say that if you don't see 10 millimeters or 11 millimeters a second of flow, which is already very small, that's enough. That's good. Our products, the Aquamaster 4, can actually read up to 6 millimeters per second. Wow. With an error of 0.1. So with that much amount of flow, you know that there is a leak lot before you actually have to perceive it. The whole idea of leak reduction is early sensing. Sure. The earlier you know, you reduce the time. Sure. And the utility was able to reduce 1.5 million liters of water in a year. And so there has been many examples of using technology and good decision making with technology in order to enable reduction in leaks, reduction in NRW, and better demand management.
That's fantastic. Wow, that's really incredible. So let's talk about digital platforms. How can those help in managing the water distribution networks more intelligently?
Yeah, I mean, we see it all around us, don't we? I mean, if I don't know if you drive a Tesla or something, there used to be a time when the computer inside a car would kind of tell you that, look, there is an obstacle, or or indicate to you that you need to change lanes or whatever. Now, certain decisions are taken by the car themselves. The car can brake if it's a hazard, or even your blood glucose monitors. You don't earlier you used to measure the blood glucose connected to you real time and read it on your mobile phone. Now they can actually take a decision to inject enough insulin to bring down the sugar. The same trend we see in process automation as well, particularly in digital use of a lot of digital platforms, both edge-based solutions as well as cloud-based solutions, and intelligence embedded inside the devices. Today's devices can not only read measurements of different parameters like flow, pressure, etc. You can actually take meaningful insights out of them, including self-verification, self-knowledge of when the instrument is failing, or even at the water network level, indicating that the health of the water network is in danger because of the kind of pressure transients that you're noticing. So more and more decisions making is now possible inside the devices, and with the help of the cloud, your compute powers have gone up. They've gone up tremendously, and there is so much that is possible with a combination of intelligent devices, compute power, and digital solutions, which actually look at all the data, being able to throw intelligent insights. And I'll give you an example. There is, in a water network, you measure pressure. Pressure measurement is a very important aspect of a water network. So typically, many water utilities would measure the pressure at different locations and would measure the flow in one or two locations. So when you put these things together with a digital platform, you could now start correlating pressure transients with flow to start making more sense of what exactly is happening. So things that are not noticeable with a human eye and not knowing, what's the nighttime flow, or missing out on facts, are now generated through decision making and through insights by combination of devices using a digital platform. So a little bit of flow, a little bit of pressure, and temperature, and you're able to exactly determine that this is the area where you need to be working on to address things, etc. So digital platforms are changing the game a little bit. It's making it more easier for utilities to try and address their demand management challenges. And I think there's a long way to go on that side. There's, with AI coming in, there's quite a bit of problems that is being addressed with that as well.
Right, but really helping utilities achieve that more proactive approach, catching things before they're catastrophes.
Yeah.
Right?
Yeah.
So let's talk about the Aquamaster 4 a little bit more. I know it's been recognized to detect leaks down to really, really, really tiny, up to 10 times faster than conventional technologies. So let's talk a little bit more about how, what makes that possible? How can it do that? And how does it change the economics around leak reduction for utilities?
So the Aquamaster 4, as I was telling, first of all, the history of Aquamaster 4 is very connected to demand management, NRW reduction, etc. So an electromagnetic flow meter is designed in such a way that it can measure fluids flows by generating a voltage across the electrodes. Now, in reality, the science of electromagnetic flow meter, or the engineering of electromagnetic flow meter, is about how to measure lower and lower voltages. I don't know if you know that the first experiment of doing this was done by the Michael Faraday himself in the Thames River. He tried to, in what was it, 18th century? I don't know the dates, but yeah, it was long, long ago. He tried to measure the flow of Thames River by inserting electrodes. He failed. Guess why he failed? He had his theories right, but several years later, people could solve the problem. The problem was that he couldn't measure the voltage. The ability to measure small voltages is not that easy. So the whole engineering of electromagnetic flow meters comes from the ability to measure much smaller voltages. So in the Aquamaster 4, typically many flow meters measure in like millivolts or microvolts. The Aquamaster 4 measures in picovolts, which is, picovolt is, think about it, it's a millionth of a volt. So it can pick up that tiny voltage without the noise, with a high signal to noise ratio. So what that ends up doing is that, you can achieve extremely high degree of zero stability. I can tell you the zero stability is 0.025 millimeters per second and this and that. The point is, I tell my customers, if you have a small township, 100, 200 houses, and one Aquamaster 4 at the beginning of the supply side, if someone flushed the toilet in the night, an AquaMaster would say, "Hey, someone flushed the toilet in the
Wow,
night."
yeah.
It's so
Precise.
that's like the amount of the low flows that it can measure. Then the other reality of flow meters is also the range. So AquaMaster has one of the highest ranges, the range of about 1,000, which means the difference between the highest flows and the lowest flows is 1,000 times, which means that you can not only use it for low flow but use it for high flow as well. At ABB, we have been focusing mainly on two areas: low flow, low energy consumption. Low flow, low energy consumption. And now with the data transmission capabilities with NB-IoT and 4G, we're able to transmit a lot more data and insights into the cloud. And our next evolution comes with the AquaMaster Plus, which will enable you to visualize the data, interpret the data, and make smart decisions as well. So that's how the journey of AquaMaster has been going in. So you can really use it, have confidence in your billing. Be sure that you will be able to detect the smallest of flows, and with pressure systems like the P100, where you can even look at 0.075% accuracy, you are pretty much having a system. And with AquaMaster Plus, you can actually literally make decisions much faster than before.
That's incredible. That's fantastic. Now, is the AquaMaster Plus, is that out available now, or is that in the future?
AquaMaster Plus, the early versions will be coming out this summer.
Wonderful.
The first versions, we will be working with the AquaMaster mobile comms product, and we will be launching it later this year. But the beauty of the AquaMaster Plus is you have all this data. I mean, I hear this from customers all the time, so much of data, what do I do? Right. So it takes that next step to convert this data into insights, which are presented in a more actionable fashion to our customers, and that's what kind of closes the entire loop of the whole cycle, right? So data, the intelligence, and action, and finally you need to act in order to do a demand management cycle, and that's where this thing all comes across from.
That's fantastic. Well, KP, thank you so much for joining us. I
Thank-
really appreciate it. Our viewers may be interested to learn a little bit more about the AquaMaster 4, or keep track of the AquaMaster Plus, or just whatever else you guys offer. So where would you send them for some information?
Yeah, I mean, first of all, thank you for having me here. And yes, please, welcome to visit our website at abb.com/flow, and check out Google up the AquaMaster if you've never heard of it. And you'd find all the material that is required. And feel free to reach out to us. And looking forward to your questions and your participation in a journey to create a more sustainable world.
Wonderful.
Thank you very much.
KP, thank you. Appreciate you. And
Thank
thanks
you.
to all of you for tuning in. This has been the Water Online Show. My name is Angela Godwin.